Team Soldier's first proposal is based on an extensive feasibility study made possible by conducting 83 interviews, multiple visits to Camp Shelby, and academic research. Three main components of our proposal from our study include virtualization, network architecture, and an implementation plan. Virtualization takes physical servers and allows them to function as VMs, or virtual machines, allowing Camp Shelby's cyber team to create a diverse array of applications and operating systems on one PC. The virtualization process is made possible through virtualization software, like hypervisors, that act as an intermediary layer between the physical hardware and virtual environments. Virtualization is also crucial to the Cactive's success as it is far more scalable than traditional hardware, which has preset resources and specifications. It also opens doors to remote cyber training, enabling collaboration with fellow military bases and government entities, transcending geographical barriers and bringing eyes to Camp Shelby's kinetic and non-kinetic training capabilities. Next, a closed-loop network needs to be implemented within the Cactive. This self-contained network ensures that if a breach occurs, the unauthorized party is prevented from infiltrating Camp Shelby's main network, safeguarding critical digital and physical infrastructure. This additional security allows for smart home tech implementation despite its vulnerabilities, as this type of tech is valuable due to its common use by prominent threat actors such as Russian and Chinese hacking groups. We also believe that it would be beneficial for Camp Shelby to become a part of the U.S. Army Cyber Command's Persistent Cyber Training Environment, PCTE, as it provides many cloud computing capabilities such as sandbox training environments where a cyber team can tailor their training based on their operational needs and standards. These sandbox environments could also allow cyber teams to train with tactics used by prominent threat actors such as the Chinese hacking group VolTyphoon, who use living-off-the-land malware techniques. As our armed forces stand at the precipice of a new era of urbanized warfare, our team has consulted both kinetic and non-kinetic personnel at Camp Shelby to propose a deployment plan that is realistic and effective. We have selected one Cactive building that can simulate a jail environment for beta testing. Tech currently in discussion for this building includes smart magnetic locks, garage doors and door openers, live camera functions, and a hackable one-building power grid within the Cactive's closed-loop network. Once the beta testing with this jail environment is deemed effective and sustainable, we envision an expanded network of 3 to 4 buildings outfitted to mirror realistic urban settings. These buildings are already physically connected by underground tunnels that mimic a sewer system, which not only means that a smaller, more testable physical compound already exists, but it also means that one of the selected buildings could act as a sewage plant within the Cactive's network. These points are just a brief overview of our main findings that could benefit Camp Shelby's cyber training capabilities, but we believe that they are crucial in creating a starting point for an upgraded Cactive that merges both kinetic and non-kinetic training for urbanized warfare preparation.